going to have a chat today about the Mig 200 pulse MIG machine. Probably more so just to do with the internal setup of the MIG machine. I've had this machine now for 2 weeks, and I've probably gone through maybe 2/3 of a roll of wire. Probably one of the downsides of the machine is that it only has a 5 kilo roll rather than a 15, but the portability of this machine is quite good. Compared to something like the old Lincoln over there that you nearly need a forklift to lift. So yeah, the new machines are just amazing in their portability. One of the first things I'd like to talk about is the roll of wire. They put a new roll in the machine. So imagine that we've got a new roll of alley and we've put it on. We undo the side nut here. One of the very first things that I like to do is set the tension. So at the moment this is set okay. And what I mean by that is that when you pull the trigger on the handpiece and the rollers start dragging the wire through the handpiece, if you let go of the trigger, if you haven't got enough tension on this roll, it will continue to spin. And what can happen is the wire will unroll off and pop off the side, and you end up with a bird's nest. So how you can fix that is this center adjusting nut. Turn that clockwise, it will tighten on a spring, which will increase the resistance. Or you can turn it anti-clockwise, which will reduce the resistance. So you need that to be somewhere where when you let your finger off the trigger, the roll stops dead straight away. It doesn't continue to spin. If you have too much tension on this nut in here, it can make it difficult for your feed rollers to pull the wire through, which can cause little fragments of the alley wire to break off and feed into the liner and eventually clog your liner up, which makes it difficult for the wire to feed through. So once you've got this set okay, then you feed your roll, you feed the end of your wire through here, through that part of the liner. And probably before we get to that point though, I've probably jumped ahead a little bit too far, because we need to make sure that we've got the correct rollers in place, and they need to be U rollers for aluminium wire. So they're a U-shaped roller. So the groove in there, if you looked in it in cross section, would be a U shape, and that's to support the aluminium wire because aluminium wire is quite soft. So we need to be able to support it. When these top rollers push down against the bottom rollers, we don't want the alley wire to be deformed, and the U shape supports it quite well. The second thing about your rollers is you need to make sure that they're the right diameter. So if they're 1.2 mil wire, which this is 1.2 mil wire, we need to make sure that we've got 1.2 mil rollers. And there's usually 2 grooves per roller. One side will be, say, 1.2 mil, and the other side might be 1 mil or 0.9. So you need to make sure you've got your rollers orientated around the right way. So you would undo the screw, slide the roller off, check out which side is which, rotate it around, put it back on, screws in. Okay, so we've got the correct rollers in there for aluminium wire. There's 3 typical types of rollers. There's the U rollers, and there's V rollers, and there's knurled rollers. So when you're using gasless wire or flux cord wire, you would use the knurled roller. When we're using solid wire, steel wire, we would use the V roller. So we need to make sure we've got the correct ones in there. So once we've worked that out, then the next big thing that needs to be checked is the tension. How much tension's being exerted here down onto the bottom rollers. If we've got too much, we can deform the alley wire and turn it from a round shape into an oval shape, which then makes it difficult to feed through the contact tip in the handpiece. So we need to get our feed, or our tension, sorry, just right. And the way I do that is I get some pliers, making sure that not I'm not touching the return clamp, and the pliers are well insulated. And I hold the wire and I pull the trigger. And if there's slippage here with minimal resistance against the pliers as I'm holding the wire. So what I mean by that is here at the end, if I'm holding the end of this wire with the pliers and it pushes away gently, or doesn't push at all, that will determine how much pressure I need to put on this guy. Whoop. So I just want to be able to stall the wire basically with minimal resistance, so that these rollers will just slip on the wire. If I've got too much tension, what can happen is that if the wire, which it will happen to you, gets stuck in the contact tip, the only place for the wire then to get fed out, these rollers are still trying to feed it through. And if it's stuck in the contact tip, the only place the wire can come out is right there. You'll open the lid up and you'll have a big bird's nest of wire just sort of sat here. Okay, so yeah, you need to have a bit of slippage there. So if it does get caught in the contact tip, the rollers will just slip on the wire. But if you haven't got enough tension down, you're going to have issues with the wire feeding erratically. So it might be nice to take note of where on this scale it sits, your alley wire and a particular diameter, and then also for steel wire and then maybe gasless. So that when you put different rolls of wire in there, whether it's gasless, steel, aluminium, stainless, different diameters, you've got a bit of a record of where this would sit. But a nice easy way of checking that is just getting some insulated pliers, making sure you're not connected any way to the circuit, pulling the trigger and trying to stall the wire. And if it slips with minimal sort of resistance, then that's about right. Just play around with that anyway. If you've got too much tension as well, it's again just feed fragments of aluminium into your liner and through here, in through here, and get fed into your liner in the handpiece cable and cause issues. And I did have that the other day. There was erratic feed and I thought it was the contact tip, changed the contact tip. But as it turned out, it was this liner getting clogged up. So I wound the wire back onto the spool and put the end of the wire through one of these holes to retain the wire on the roll. Then I unscrewed this guy and took the handpiece away from the machine. And I've got a compressor with an air nozzle, and I was able to blow out bits of debris from the liner. And there was a lot came out, and that's only in 2 weeks and about 2/3 of a roll of wire. So yeah, I think it's an important thing to do to clean that liner out, and it just keeps your alley wire feeding smoothly. And you'll actually feel it in the gun as you're welding. If you feel it sort of catching, I guess, in the liner, it could be one of two things. It could be a contact tip, or it could be both, I guess. It could be your contact tip's worn out, or your liner needs a clean out or replacing. Okay, so that's a big one too, to make sure you've got the correct liner in there for aluminium. It needs to be a Teflon liner rather than a wound steel liner, just to help with the softness of the aluminium feeding through, and a shorter lead as you can possibly get for alley as well, because it doesn't like to be pushed long distances. Okay, so we've got our tension right, got the rollers correct, 1.2 mil wire, and we need to have 1.2 mil rollers, U rollers. Tension's right, got the tension right on our roll. Then our thing that we need to look at now is polarity. So for solid wire, we need the handpiece to be electrode positive, okay? And our return clamp or work clamp needs to be negative, okay? So we've got the negative here for our return, and we've got our handpiece on the positive. If we were welding with gasless wire, we would need to swap the polarity around, and on this MIG, it's quite easy. We just take this one and put it into this guy here, okay? The next thing that we need to worry about is that we've got the correct contact tip in the handpiece. So what I mean by that is that we need to make sure that that is a 1.2 mil alley contact tip, rather than just a 1.2 mil contact tip. It needs to be a 1.2 with an A on it, because the hole size in that contact tip is slightly bigger than 1.2 to allow for the aluminium wire to expand and not get bound up in the contact tip. And obviously, if we then need to, sorry, it's just out of shot at the moment. We then just need to make sure that we've got our shroud on. Okay, so that's just a brief run through on setting up your welder, on a few mistakes that people, when they're initially setting up their welders, no matter whether it's aluminium, steel, stainless, gasless, um, don't get quite right, and that can cause issues and make it quite frustrating. Just going back to polarity quickly, there's gasless wire is hollow, it has a flux on the inside. So the cross-sectional thickness of gasless wire is quite thin when you consider that it's hollow. So 2/3 of your heat is at the positive side of the pole. So if we've got our handpiece positive, 2/3 of the heat is in that wire as it's coming out into the arc, and it's too hot for that wire. If it's solid wire, it can handle the heat, the positive side. And that's why we need to swap it for gasless, so the handpiece is actually negative and more of the heat's in the job. Okay, thanks for watching.